All right, now let's talk about PIV-NRT. PV equals nRT. This is the last piece to our stoichiometry puzzle. So really quick, what all that stands for. This is based, of course, off of our gas laws, Boyle's law, Gay-Lussac's law, Charles's law, Avogadro's law that we learned way back in Unit 2. So P, that's your pressure in atmospheres. V is volume in liters. N is moles. T is your temperature in Kelvin. And then R is the universal gas constant. So that's the constant. It's always the same. Constant means it doesn't change. So it's the number that relates all of these variables together. And it's always 0.0821. And it's got to include all these units. Liter, atmospheres over mole, Kelvin. So whenever we use PIV-NRT, we have to use liters, atmospheres, moles, and Kelvin. Otherwise, it's not going to work because of that 0.0821. So I'm going to write that 0.0821 up here because I'm going to erase the rest. And that way we have it to reference. So PIV-NRT, PV equals nRT. That is what we are working with here. So this allows us to convert volume of gas to moles and moles of gas to volume. So it's used for gases. We know we can use molar mass for solids. We know we can use molarity for solutions. So now we have something we can use for gases, PIV-NRT. So we can get anything into moles. All right, so what volume does 16 grams of O2 occupy at STP? Remember, STP means standard temperature and pressure. So that is 273 Kelvin, or 0 degrees Celsius, and 1 atmosphere. So I've got 16 grams of O2. I'm going to convert that to moles because we know when in doubt, convert your grams to moles, people. It's O2, so I'm going to use 31.998 grams for every mole for my molar mass. And it's O2, and that gives me 0.5 moles. And now I can plug that into PIV-NRT. So P, pressure, 1 atmosphere. Actually, I am going to leave the units off. I'm going to say them out loud, but I'm going to leave them off when I write them. So 1 atmosphere times volume. We don't know that. That's going to be our X. I'm just going to leave it as V equals N moles. That's 0.5. We just calculated that. Times R. That's the universal gas constant. It's always 0.0821. Oops, our point there. 0.0821 times our temperature, 273 Kelvin. So I'm going to multiply those all together. I'm going to end up with volume equals 11.2 liters. And that's it. So it's nice. We have an equation. As long as we have pressure, temperature, and volume, we can figure out moles. Or if we have moles, and a couple of the other ones, we can figure out whatever other variable we need. Remember, R doesn't change. R is always 0.0821. We never have to solve for R. So let's actually scroll down. So I want you to scroll with me. We're going to do a stoichiometry problem. Let's go ahead and do number 6. So in this one, it says, what mass of P4 will completely react with 2.50 liters of hydrogen gas at 0 degrees Celsius and 1.50 atmospheres of pressure? So I know I need a VCA table, but I don't have any moles. I don't have any grams to convert to moles. But I do have all of this lovely information about the hydrogen gas. So I can use that information to get moles. So 2.5 liters, that's a volume. 0 degrees Celsius, that's a temperature. 1.5 atmospheres, that's a pressure. So I could do 1.5 atmospheres times 2.5 liters equals, I need moles, so N times 0.0821 times, convert to Kelvin, 273 Kelvin. And then I'm going to throw that in my calculator. 0.5 times 2.5. And I get for H2 0.16 moles. Now I'm going to let you figure out the rest because BCA tables are a different learning target. But see, I can use PivNert to get my moles. If I look down at number 7, I start with grams, so I know how to get that to moles. But at the end, it's looking for what volume of gas. So at the end, if I want to figure out a volume of gas, I can take my moles from my BCA table and use PivNert to find volume. And that's it.